So now we're done with the Bernoulli trials, at least for random variables that are based on Bernoulli trials. Instead, we're going to talk about what's called an arrival process. And the random variable that we use to describe this is one called the Poisson random variable. The Poisson just counts the number of occurrences of a rare event in a unit time interval or space interval. If we have the average number of arrivals per unit time, we're going to call that lambda. And if that's the case, then we're going to say our support is another one of these countably infinite sets that starts at 0, 1, 2, and goes all the way up to infinity. Probability mass function is written as e to the minus lambda times lambda to the x divided by x factorial. And the mean for this is lambda, and the variance is also lambda, it turns out. So let's look at an example. On average, 5 cars arrive at a car wash every hour. Suppose that we have a Poisson distribution. What's the probability that no car arrives in 1 hour? Okay, so that says what's the probability that x is equal to 0 given that lambda is equal to 5. And let's also look at the probability that 48, 49, or 50 cars arrive in 1 day, which we're defining to be 10 hours. Now the interesting thing about the Poisson random variable is you can scale it. If you have 5 cars per hour on average, then if you go for 10 hours, that means you're going to have 50 cars on average in 10 hours. So we can scale that up and scale it down. The function that we're going to use for this is either dPois or pPois, and let's go over to R and look at how to do that. We're told that lambda is equal to 5 cars per hour, so we're going to put lambda in here, and we're going to say x is Poisson lambda. And so if we want to know what the probability that x is equal to 0 is, we can either use dPoisson lambda comma 0 comma lambda, you can put 0.0067, or we can use d of x of 0, which gives us the same thing. Now when we're talking about a 10-hour day, that means we're going to have on average 50 cars arrive, and so we're going to change lambda to be equal to 5 times 10, and then we want to say what's the probability that x is between 48 and 50 inclusive. So we want 48, 49, 50, so we're going to use the CDF and the diff function to get that, and we're going to see that we have 16.7% for that probability.